Hi, so this is T. Srinivasu working as a Senior Assistant Professor in EC Department at Sri Vasavi Engineering College. Today, I will discuss about the interrupts of 8086. So here, what is the meaning of interrupt? So the general meaning of interrupt is to break the sequence of operation. So that means whenever the microprocessor is executing the main program, in that case, if any interrupt is coming here, if the interrupt is coming here, then the microprocessor stop executing current program. So here, the microprocessor stop executing the current program. It goes to another program called as the interrupt service routine, simply called as ISR. Okay. Once ISR is executed, then execution is comes back to the main program, and the main program is continue to execute. So this is called as the interrupt. So interrupt has many applications. That is, if you take whenever the power is failed, then the content of the previous work is saved. So that is done due to the use of interrupts. Okay. So here next I will go for the types of interrupts. So types of so basically there are two types of interrupts. One is hardware interrupt, and second one is software interrupts. So in this hardware interrupts, again, these are divided into two types. One is non-maskable interrupt. Next one is maskable interrupt. That is non-maskable. So hardware interrupt means, so these interrupts are generated by the external devices. That in 8086 we have two pins, that is pin 17 and pin 18. So this is 8086. So pin 17 belongs to NMI, non-maskable interrupt, and pin 18 belongs to the INTR. Okay. Now what is meaning of non-maskable interrupt? So the interrupt which cannot be disabled, that is called as the non-maskable interrupt. Example is this one, non-maskable interrupt. But in case of maskable interrupt, so these interrupts can be enabled or disabled using the flag, that is called IF, interrupt flag. Okay. That means these interrupts can be enabled or disabled using IF flag. If IF equal to 1, interrupts are enabled. If IF equal to 0, so those are disabled. Maskable interrupts are disabled. Okay. So therefore these interrupts can be enabled or disabled using the interrupt flag. Example for this type of maskable interrupt is INTR, this one. So example is INTR. So that means whenever it is disabled, that means when IF equal 0 in the flag register, So even though interrupt is coming at this pin, the microprocessor does not take because it is disabled. So this is about the hardware interrupts. And coming to software interrupts, so in these interrupts are generated due to execution of INT N instruction. Execution of INT N instruction, where N is the integer ranging from 0 to 255. Means totally we have 256 interrupts. Totally we have 256 software interrupts. Okay. So this is about the types of interrupts. Then we'll discuss about then we'll go for the next, that is sources of interrupts. So what are the sources of getting the interrupts by the microprocessor? So first source of interrupt is interrupts generated by the external devices. So those are called external. Those are called external interrupts. And second one is interrupts generated due to the execution of INT N instruction. Okay, so these are called internal interrupts. And third one is interrupts generated due to some exception condition. For example, that is divide by 0 error. So because of these three reasons, we are getting the interrupts. So those are the first one, the external interrupts, that is those are generated by the external devices, and internal interrupts, those are generated due to the execution of INT N instruction, and some interrupts are generated due to exception conditions like divide by 0 error. So these are the main three causes of the interrupts. Okay, so then I will go for the next topic, that is interrupt vector table. So that means whenever the microprocessor is getting the interrupt, then it stop executing the main program and goes to another subprogram called as the interrupt service routine. The starting address of every ISR is stored in a memory. Memory and stored in a memory of size 1 KB, 1 kilobyte. So this memory is called as the interrupt vector table. Okay, that means starting address of every ISR is stored in the table, and that table is called as the interrupt vector table, and that vector table size is 1 kilobyte. So this address range, the address range of this memory is 000H2 000 3FFH. So this is the address range of the interrupt vector table. Okay. So this starting address of every ISR is also called as interrupt vector. vector. So the starting address of every ISR is called interrupt vector, and all these vectors are stored in a table that is called as the interrupt vector table. Okay, so this is about the interrupt vector table, and we can draw the table for this. That is, this is the interrupt vector table. So totally we have 256 interrupts. Okay, so type 0 to type 2 to 5. So this is the type 0, and the second one is type 1. Type 1 interrupt. Next, this belongs to type 2, and this belongs to type 3, and this belongs to type 4. So type 4. Okay. So this type 0 interrupt is called as the divided by 0 interrupt. Okay. And type 1 is called as the single step interrupt. Single step interrupt. And type 2 interrupt is called as the non-maskable interrupt. Therefore, NMI is also called type 2 interrupt. And type 3 belongs to breakpoint. So breakpoint interrupt. Next, type 4 belongs to overflow interrupt. So because already these are defined, so therefore these are called dedicated interrupts. These are called dedicated interrupts. Okay. So totally we have 5. Next, from type 5 to type 31. So type 5 to type 31. So these are called reserved interrupts. So these are called reserved. And reserved interrupts equal to 27. So type 5 to type 31. So those are the reserved interrupts. Okay. Next, type 32 to and last type 255. So these are the available interrupts. So type 32 to, so these are called available. Available total equal to 224. So total equal to 256 interrupts. So type 0 to type 2 to 5. Okay. And every ISR starting address is present in these 4 locations. That means every ISR starting address contains 4 bytes. Contains a 4-byte address. Okay. So 2 bytes for IP, 2 bytes for CS. So code segment address, that is 2 bytes, and instruction pointer address, that is equal to 2 bytes. Okay. So total equal 4 bytes are required, and those 4 bytes are stored in the 4 locations in the interrupt vector table. That means each type requires 4 bytes. So in the 4 bytes, so first it will store the First it will show the IP address, then it will show the CS address. First two locations in this type 0, assume type 0, in the first two locations it will show the IP address of the ISR, and CS address in next two locations it will show the CS address. Okay, now how do you know the microprocessor on what location it contains the corresponding ISR address? Okay, so that depends on the type interrupt. For example, I am taking the one example, INT 4 interrupt. For example, the microprocessor executing the INT 4 instruction. That means type 4 interrupt, where n is this is INT n, where n is the integer, or that is called type number, that is ranging from 0 to 255. That is ranging from 0 to 255. So whenever the microprocessor executing this type 4 interrupt, then in what location this fourth type interrupt ISR is present. So for that, the microprocessor multiplies the type number with the 4. That is, n is multiplied with the 4. In this case, type number equal to 4. So 4 into 4 equal to 16 in decimal. If you convert this into the hexadecimal, that is equal to 10H. Okay, so that means the type 4 interrupt ISR starting address is present in the 4 locations. So this I am taking this. Okay, so that start in this interrupt vector table. So 00010H 00010H is the address of the type 4 interrupt in the interrupt vector table. So in this 00010H location, 10H location, and 000 next location, 11H location. In these two locations, we have the what address, IP address of the ISR. Okay, next 00012H and 00013H. In these two locations, we have the CS address are present. So the microprocessor fetches the address from these locations, that is IP address and CS address, and goes to the ISR. Okay, so once ISR executed, again the microprocessor go back to the main program and it start executing the main program where it was stopped. Okay, so this is about the interrupt vector table. And if you go for the address of this, so the starting address is equal to 0000H, and ending address of this is equal to 000 3 0000 3FFH. Okay, so type 4, so type 1 total equal 5 interrupts. So for this, the ending address is 00013H, and type 5 starting from 0014H. Okay, and type 31 ending with the address that is equal to 0007FH, and type 32 starting with the address 00080H. Okay, so 00080H to 003FFH, those are the available interrupts. Okay, and this address range 00014H to 007FH, these are called this address range is reserved for the reserved interrupts. Means these interrupts are reserved for the future microprocessors. So these are not used in the 8086, and these interrupts are used in the type 5 to type 31 are reserved for the future microprocessors. And coming to this one, dedicated interrupts range 0000 H2 00013H. So those are the dedicated interrupts tot equal to 5. So this is about the interrupt vector table. Okay. Then I will discuss about the interrupt response. That means whenever the interrupt is coming, what happens? That is called interrupt response. Okay. So assume the microprocessor executing the main program. So this is the main program. If any interrupt is coming here, at this point, okay, so the microprocessor stop executing this program here. The microprocessor stop executing the program here and goes to another program called as the interrupt service routine. But before going to ISR, the microprocessor has to some work. What is that work? So before going to this ISR, first it has to save flag register. That is, save means push flags onto the stack. So all these are stored in the stack. So first it will push the flags. Next, clear the interrupt flag so that it does not take another interrupt. Next, clear trap flag, single step interrupt, that is called trap flag. And next one is it will push the content of CS register. That means address of the next instruction. Here next instruction is there here. This address, code segment address for this instruction, code segment address is pushed onto the stack. Next again push instruction pointer address. So for this instruction, the IP address is pushed onto the stack. Next, fetch ISR address. Fetch ISR address from the interrupt vector table. Once this work is done, then it goes to ISR, interrupt service routine. So in that ISR, first we have to save the registers that are used in the main program. Up to now, what are the registers we are using here? So those registers should be saved into the stack. Okay, that is push registers, then it execute the ISR program. So once ISR is executed, then we have to pop the registers. So these are used in the main program. Next, at the end of the ISR, we have to write instruction called as the IRET, interrupt on return. Once the microprocessor executes this instruction, it knows that it is the end of the ISR, so that I have to go back to the main program. Okay, so where the main program, this instruction address is got by the microprocessor, so that is already we have saved in this stack. So we have to pop this address so that the microprocessor come back to the main program. Okay, so once IRET instruction executed, so in the reverse order it will pop. So pop first instruction pointer address, that is this one. Next pop CS and this address. Next pop flags. Once IP address and CS address obtained by the microprocessor, then it goes to the next instruction in the main program. that is at this point, at this intersection, the microprocessor goes to this address and execute the main program. So this is called as the interrupt response. Okay. So this interrupt response explains the how or what happens when the interrupt is coming. Okay. So first it saves these contents, then it goes to the ISR, then it push the flag, it push the registers, then execute the ISR program and pop the registers. Next execute the IRT instruction, then pop IP, pop CS, pop flags, then go to the main program. Okay. So this is the interrupt response. Okay. So this is about the overall interrupts in 8086 and also types. Next interrupt vector table, then interrupt response.